You can see in the background our system to know how much water we're applying and to do precise irrigation. Adaptable system. We can take it on any farm. We're going to find something to put this thing on anywhere, not just here in Brazil, but anywhere in the world. How we doing, irrigators? We're here today in Sao Paulo, Brazil, on the family farm, my wife's family. This region in Brazil is super famous for citrus. It's an old citrus region. You can see in the background our citrus trees. Right now, we're in a planting that has papaya and avocado. Don't mind the weeds. We're in the middle of trying to clean up the weeds, but we had a nasty storm that just came through and dumped a bunch of water, 4 inches last night. And so everything stopped, but we're getting on top of that. And that's not the point of this conversation today anyway. We're here to talk about irrigation management. Because this papaya is a new crop for us here in the family, we installed a soil moisture sensor to measure the roots, to know how much water we're applying, and to do precise irrigation management with this crop. It's already helping out a lot, and we've already cut the runtime down to maximize leaving the water in the root zone and to maximize our efficiency.
Charles, what's the correct way to install the probe?
The best way to install a probe is close to the plant. We're about 6 inches from the plant because I wanna capture exactly what's happening in the root zone and capture that entire root zone, so I know where the crop is pulling the most amount of water, and very close to an emitter, because here in this soil that we have here in this region, we're at about 50% clay. That's a big contrast to where I cut my teeth in Florida, where it's 95% sand. So what we have to do here in this clay is put the soil moisture sensor close to the emitter so that we make sure that we wet the entire profile where the probe is installed, and so that we get good coverage of the probe. So we really have a better idea of what's going on with our irrigation.
How many sensors do you have?
On this probe, we've got 6 sensors, one every 10 centimeters or 4 inches until 2 feet. It's a 2-foot probe. So we have 6 sensors in 2 feet. What we have here is a basic post that you can find anywhere here in Brazil. It's eucalyptus, just like a pine log. We've got our clamp back here that fixes our arm to the post, and this is adjustable from anywhere from 1 inch to 6 inches. So it's an adaptable system. We can take it on any farm. We're gonna find something to put this thing on anywhere, not just here in Brazil, but anywhere in the world. And we made all of our material that we used here is robust. This iron that we've painted here to make our arm, our support arm here, is made here in Mogi by a local guy, and it's really, really, really strong, because here we have the space open on this arm to mount a weather station, to put a rain gauge. Any type of sensor that we want to put here, we have space to put it here. We mount it right here. It's solid enough to put anything on it. It'll handle the weight. The thing is solid. Our box that we found is a telecommunications box. It doesn't heat up in the sun. It protects our technology because it has a very thick seal, and everything stays protected, like I was saying.
What about the temperature in our box?
The temperature inside the box stays cool because the type of plastic doesn't heat up. It doesn't conduct the heat energy, and everything stays cool and protected. Our cables, where the cables come out, is a really thick rubber seal, so no dust, no water gets in. Everything stays really well protected. This box is really well designed, and that's why we chose it. Inside here, we've got a really big battery, a 4.5 amp hour battery, which is way more than we need. We can, without a solar panel, without sunlight, we can run just on our battery for 2 weeks, no problem, without thinking about it. And what I mean by run, I mean we're going to continue to collect our data every 20 minutes. We're going to continue to send that data to the web every 20 minutes. and we're going to have that data available for our client without worrying about anything. But we have this solar panel that's 3 times bigger than we need. Why? Because even on a cloudy day like today, it's still going to fill up our battery. It's still going to recharge our battery, and we're still going to stay on top of our data. Keep that battery life healthy. Keep that battery life running, and we're never going to lack our data. Inside this motherboard that we have here, we've got data storage. We even have a backup little battery in case something happens. Our solar panel gets blocked out by corn or a tree limb. It gets broken. Something cuts the wire. We're still going to be sending data because our connectivity, our internet is provided by satellite, so none of that's going to impact our satellite receiver. And because our batteries extra large, and we have our backup battery, we have redundancy built in. Our storage, or data storage, we have enough data storage on this thing now to store I think the math that we did was 150 years worth of data without worry. So what I'm trying to say, in summary, what is Charles trying to say to me right now? We've got a probe here in Brazil that we're using to do irrigation management. We've got a really robust system that we've designed that will be released in January that will go, if it works here in Brazil in this tropical climate that dumped 4 inches of rain on us last night, and gets to 95 degrees in the daytime in the summer, if it works here, it'll work anywhere. Our idea is that we made it here in Brazil to export and put it in anywhere in the world. We've already got clients calling us in other places in South America, in North Africa. We've got other places to take this equipment. We know it'll work because it works here. And I'm excited to bring it to the U.S. and bring it back home and talk to my friends and colleagues there, show them what we can do with this system, and let it rip.
And to install all this stuff, we don't need farmer, we don't need any structure.
Exactly, Alan. We don't need anything from the farm. We're going to show up. It's all basic stuff that you can find anywhere. That's the beauty of our system. It's simple, it's robust, it works anywhere, and with a pair of post hole diggers, you can make a hole and throw this thing in the ground. Of course, I like to use a soil auger because it's a little bit faster and easier for me, especially in these high clay soils. When it's really dry and that high clay soil gets really hard, my auger keeps on working and I don't have to beat myself up with a pair of post hole diggers. But listen, it'll go anywhere.
What about the platform, the datas?
The platform is in development right now. It's almost ready. It'll be ready in January, like I said. It's going to simplify all these data. You're going to have 6 lines on a graph, but we're going to simplify that data to say, look, irrigate or don't irrigate. And if you do irrigate, you're going to want to put about this much out, We're going to simplify all this decision making. Oh, but what about the weather? It looks like it might rain on Wednesday. The next version of our website that we're already thinking about is incorporating some of this artificial intelligence to help us make these decisions without spending so much time trying to figure this stuff out. It's not rocket science, We don't always have a lot of confidence in our weather forecast, but at least we can say, look, we've got a 90% probability of rain on Wednesday, and it's looking like it's going to be half an inch of rain. We can already say, even if it doesn't rain that half an inch, even if you only get 1/10 of an inch or something like that, we can already say, look, it's going to at least be cloudy. Our evapotranspiration is going to dip. We're not going to have such a high demand. We can start playing that game. Do I turn on the pivot or not? Do I turn on the pump for my drip irrigation or not? We can already start to play this game, and we can run those numbers in AI land, in virtual land, right? And we can already estimate, okay, if you play this game, if you don't irrigate and it does rain, you're good. But if you don't irrigate and it doesn't rain, how bad am I off? Well, we have a probe in the ground. We already know what kind of soil moisture we've got. Let's say we got 3 days left of moisture and it's going to rain in 2 days. That's the game we're talking about playing. with this technology and helping growers make these decisions to save water, to save money. And it's not about
Just a math model.
yeah, no. It's all this stuff is to simplify the life of the grower. And it's not about saying, oh, you're going to produce 10 boxes more or 20 bushels more. It's not about that. It's about every single year, every single season, you're only irrigating what you need. So in the long term and in the short term, you're saving water, which is saving energy, which is saving money, which is putting more money back in the pocket of the grower. I don't care about producing more. I don't care about promising more in production. That's something for somebody else to do. What I can say to you as our producers is that I can help you save water every harvest.